Hi, welcome back. This is Arish from jtechs.com. This is a video series on Android programming. In this video, we will have a look at Android UI, specifically views and layouts. A view is a parent class for all the UI elements. Every visual element we see on an Android device is a subclass of view. Another important class is called view group. A view group is a view that contains other views. This is basically a container. All our layouts are subclass of view group. Let's look at hierarchy of the class. We have a first base class view, and there are subclasses, the main ones being view group and text view. Under view group we have our layouts and some other classes as well. For this video we'll concentrate on the layouts. We have three important layouts: the linear layout, relative layout and frame layout. The table layout is a kind of linear layout, so that is a subclass of linear layout. All our fields like button, edit field, edit text field are all subclass of text view. What is a layout? A layout defines the visual structure of a user interface. A layout organizes our elements on the screen to create a view. Let's say we have two fields, a text field and a button. We can place them on the screen in many different ways. We can place them one below the other and align them in the center of the screen, or we can place them next to each other on the same line, or we can place them one below the other and align them to the right side of the screen. Let's look at linear layout. A linear layout lays out the elements in a single direction, either horizontally or vertically. Let us look at an example. Here I have a simple Android application which displays Hello World. By default, Android apps are created using relative layout. Let us create a linear layout using linear layout tag, and we need to specify height and width of the layout. We will get back to what this match parent is in a moment. I will provide the layout height, and we need to specify the orientation of our layout, that is, either we will display the elements horizontally or vertically. Specify the orientation, say vertical. Let's now add few elements. I'll add a text view, and I will specify width as match parent. That means it takes the width of its parent. Layout height as wrap content. That means the height of the view will be as much as it can fit the content. I will display a text called Hello World. So we have a Hello World field. You cannot visually know what's the height and width of this field, so we can add a background color to identify the height and width of the field and provide some color. Now we see this field has taken the complete width of the parent. Now let's copy paste this to add, say, three fields. I will change the color of each of the fields. You can see there are three elements, all one below the other. If I change the orientation of this layout to horizontal, we will see that fields are displayed on the same line Since the width is provided as to take the complete width of the parent, we cannot see the other elements. To make them visible, we can change the height and width to wrap content. So take only the width as much required. Now we will see there are three fields one next to each other. Next we will look at relative layout. In relative layout, each element's position is defined relative to its sibling or its parent. You define a field and we specify where this needs to be displayed. Let's look at a demo. I will delete this and let's create a relative layout. For the relative layout also we'll specify the height and width to match parent. Next, let's add a text view. And we'll have a text hello world. And we will have a width and height to wrap the content. Let's have width as to match the parent. We have hello world text. Let's put a background color to identify where exactly it's positioned. Okay. So let's add another text view. This time I will provide width as only to wrap content. And let's change the background color. So you can see the field here is placed on top of each other. So to place them related to each other, we need to specify, say this field I want to place it below the first field. Further we will specify ID for the first field. ID I will say view 1 and here we specified below view, it is displayed below the view 1. Similarly, you can specify it has to be right side of the first view. And say align right to that view. So this view is relative to the first view. So any changes to the first view will reflect also on the second view. Let's say I will add some padding or margin. Without margin, say I will say 10 dp. So if you see, this is related to the first field. That's how we use relative layout. We specify the properties related to its sibling or its parent. Frame layout allows us to display elements on top of one another. Let's look at example. Frame layout. Again, we'll specify the height and width for the layout. To match parent. Now let's create text view. We'll add a background color and let's specify height and width. Say I'll say 300 dp. We will look at what is dp in a short while. Look at the layout. We see we have a text view with color green. Let's add another field. This time I'll add different color. We'll see that element is on top of each other. If I reduce the height and width of second element, we can see both are there on top of each other. We can play with padding, margin and specify the height and weight to place on top of each other. What's the main use of frame layout is to display the frame. For example, the first view, assume this is an image of your own photograph and you want to display some kind of frame around that, on top of that, or you want to put some kind of badge on top of that. Then second view, you can have an image which displays some kind of icon or something on top of that image. That's why it's called frame layout, basically used to create frames of for your photos. Let's look at basic attributes that you need to know while working with layouts. There are three main attributes. First one is size, second gravity, and margin and padding. Let's look at each of them. You can specify size of element in three different ways. As we saw in the example, we can specify match parent or wrap content. Match parent means it takes the same height and width as of its parent. Whereas wrap content, it will take only the height and width that is required to display the content. The third and most important one is by specifying DP. What is a DP? DP means density independent pixel. We should not, or it's not recommended to specify height and width in pixels. Instead, we should specify in DP. Android will calculate the pixel by using this DP. Android calculates this using the formula dp multiplied by density ratio of the device. Each Android device will have a density ratio. For example, the medium density devices has a ratio 1 and high density HDPI has 1.5 as a ratio and XHDPI is a ratio of 2. Android has specified these ratios on a general basis. Let's look at an example on what happens when you specify height and width in pixel versus DP. Let's say we are creating an element and specifying the height and width in pixels, say 100 pixels each. On a normal device where the density is a normal density, that's a MDPI device, our element would look like something like this. It has height of 100 pixel and width of 100 pixel. Same application on a double density device like XHDPI would look something like this. Since the density is high, there are more pixels, so 100 by 100 pixel would look something like this. We can see our app considerably looks shrinked on a bigger device. On the other hand, if you use DP as a unit to specify height and width on a normal device, that's a normal density, Android will calculate the pixels by multiplying our DP into density ratio. For normal device, the MDPI device, the density ratio is 1, so pixel is 100 into 1, that is 100 pixels. And when we display the same app on a double density device, that is XHDPI device, the density ratio is 2, so Android will calculate the pixels by multiplying DP value into density ratio. In this case, 100 into 2 is 200 pixel. So the view would look something like this. As we can see on both the devices, our app would look very similar. When we are designing our user interface, it is always recommended to use DP instead of pixels. The next important attribute is called gravity. Gravity attribute is used to position our element in the view, basically align them in different ways, either top or bottom on the right side. There are two important attributes. First is the gravity and gravity. What's the difference? Layout gravity positions the element with respect to its layout or its parent, whereas gravity positions the content of a element. Let's look at an example. Let's get back to linear layout that we earlier saw. So we have a linear layout, three fields. Let's say I will take only one view and specify height, say 200 dp and height of 200 dp. So we see this rectangular shaped view. Let's look at gravity. By default it is aligned to the left and top. If I want to align it to the bottom, we can use Android layout gravity. I say bottom. You can see the field has come to the bottom of the screen. Whereas if I want to align the content within the element, it's allow over text, I need to use attribute called gravity. So I will say center. See, the content allow word is in center. So that's the difference between layout gravity attribute and gravity attribute. And another important fields, the attribute is padding and margin. This is the element, and when you specify layout margin, there is a spacing between the element and its parent. This is margin. Whereas padding is a spacing between the content and the border of the element. Let's create a simple screen, a login screen using linear layout. We will look at example of nested layouts in this case. We have a linear layout. We need to display them vertically since we have three rows, say first row, second row and third row. So we have a linear layout that is displayed vertically. The first I need to add two fields, user and the field. For that I will add a text view. Since we have two fields, we need to have another layout, linear layout, that is oriented horizontally. And I will specify height and width to match the parent. Probably only width should match and the height should be wrap content. Inside this nested layout, I will add my text view. Say user, width to wrap content, height also wrap content. Next we'll have a edit text. So we have two fields, the text field, text and edit text. You can see from the outline here, the width is wrap contents. For this it should probably be, say I will say 400 dp. That looks like too much. I'll say 200 dp. So you can, this is a text user and a field. Similarly, add another row for the password. So we have two fields not aligned exactly the way we want. Then on the next we will have a button. The button we need to align to the right side. So we'll use gravity. Should be layout gravity. So we are aligning the element itself. So button is to the right, but we need to fix these views. So when we have elements like this, so with different height and width, we can use something called weight to specify how much width it's supposed to take. Let's say layout weight is say 1, and for text field also you specify 1. What it does is it calculates, it sums up these two weight and divides the width available between those two childs. In this case both will get around 50% width. When a specific weight, we should specify the width as 0 dp. So we can see both fields taking 50% of the spacing. But in our example or in our screen we see the field supposed to take now the more width compared to the text. So we'll change the weight so that edit text gets more weight, that is 2. Now the total width ratio is 3. Out of 3, one part of the 3 is for the text view and the 2/3 of it is for text, edit text. So it looks much better. So password is here, this is field is here, and we need to align this password to the right of its view. For that we will use again gravity. Right. So now it looks very similar, the password field and the text field. Let's do same to the user field. I need to say 0 dp. So now our visual UI looks much better. Of course the text I specified is supposed to be a values in string XML. That's ideally how we will do that. Just for demo purpose I have put a text inside this XML. So you get the idea. So how you lay out your elements using layout. Thank you for watching. For more videos please visit jtechnics.com.